In the realm of science, few names hold as much weight as Sir Isaac Newton. Renowned for his groundbreaking discoveries, Newton's intellect reshaped our understanding of the natural world. Born on Christmas Day in 1642, this English mathematician, physicist, and astronomer would go on to lay down the foundational principles of classical physics. Let us first venture into his magnum opus, the laws of motion. Newton's first law, often described as the law of inertia, tells us that an object will remain at rest or in uniform motion unless acted on by an external force. This revelation proved to be the cornerstone of modern mechanics, describing the predictable nature of movement. Transitioning to his second law, Newton brilliantly articulated how the force on an object is directly proportional to the acceleration and mass of that object. Simply put, this law explains how forces cause changes in the speed or direction of an object, essentially how our car accelerates when we step on the gas pedal. His third law, famously known as the principle that every action has an equal and opposite reaction, further cemented his legacy. This law illustrates how forces work in pairs, exemplified beautifully when we swim and push against the water, propelling ourselves forward. Yet, Newton's genius did not stop there. His insights into gravitation were equally transformative. In his work, Mathematical Principles of Natural Philosophy, Newton introduced the inverse square law of universal gravitation. This law postulates that every particle of matter in the universe attracts every other particle with a force that decreases with the square of the distance between them. It's this principle that explained the mysterious pull that keeps planets in their orbits around the Sun. Legend has it that the idea of gravity struck Newton while observing a falling apple, a moment that serves as a metaphor for the beauty of simple observation, leading to profound insight. The elegance of this theory allowed for a unified understanding of celestial and terrestrial mechanics, a feat unparalleled at the time. Newton's brilliance also extended into optics. He discovered that white light is composed of a spectrum of colors. Through a series of experiments with prisms, Newton demonstrated that light could be split into its constituent colors and recombined, unveiling the fundamental nature of light itself. In mathematics, Newton developed calculus, a revolutionary tool that enables us to understand changes and motion in a more intricate manner. Although credit for calculus is shared with German mathematician Gottfried Wilhelm Leibniz, Newton's contributions remain indispensable. As our exploration concludes, we recognize Sir Isaac Newton as a titan of scientific thought. His discoveries not only catapulted humanity into a new era of understanding, but also provided the building blocks upon which future scientists would stand. In contemplating his legacy, we are reminded of the power of curiosity and the impact one mind can have in illuminating the mysteries of our universe.